All right, so these are the half angle formulas, and you can see them on your reference sheet. But one thing I want you guys to know is that even though the formula has plus or minus right there, you're never going to do both plus or minus when you're using these formulas. You're either going to do the positive square root or the negative square root. So it just depends on if the sign of half of t is positive or negative, and same thing for the cosine. And then for tangent, you can use either one of these identities. They will give you the same value. All right, so you're going to need your own paper. And today we're going to be doing section 7.3, day 2, half angle formulas. All right, and so the first ones, for example 1, we're going to find the exact value. So a lot of times on these formulas, when it asks you to find the exact value, they're asking you to use the formula in reverse. So let me show you what I'm talking about. So for A, we have the negative square root of a fraction. The numerator is 1 minus the cosine of 660 degrees. And then the denominator is just 2. Now, we don't know what the cosine of 660 degrees is, but we don't have to know what it is. We can use one of these half angle formulas. So I'm going to scroll up, see if I can get it all on one screen. There we go. Okay, so if we're looking at this, and we're looking on this side of the formulas, that looks the most like the sine, because inside the square root is 1 minus the cosine. And so this is going to be the sine of half of an angle, and the angle that's half of is this 660. All right, because in the formula, that was your t. So our t is 660 degrees. So we put that same t there, which means we'll take half of it. All right, and then half of 660 degrees is 330 degrees. All right. Now, you may not know what the sine of 330 degrees is, but we can find it because it is special. Now, it's not super special. The super special angles are 30 degrees, 45 degrees, and 60 degrees, and the quadrant angles. But it is a multiple of a special angle. So what first thing we're going to do is determine what quadrant we're in. So 330 degrees is in quadrant 4. And then, just like the old days, we're going to find the reference angle. All right. So the reference angle in quadrant 4, you take 360 degrees and subtract the angle from it, and that gives you an angle of 30 degrees. So 330 degrees is a multiple of 30 degrees, and you probably already knew that. All right, so then in quadrant 4, the sign is negative, but I actually already knew that that was going to be negative, because if we take the negative square root of something, it's definitely going to be a negative. So that kind of got covered twice, which is good. And then for reference angle of 30 degrees, we use the 30-degree finger, which is this finger. And then it's the square root of the bottom, which is 1 over 2. So that is the exact value of that original radical fraction thing. Okay, so let's look at another one. So for B, we have another fraction. The numerator is the sine of 450 degrees. And our denominator is 1 plus the cosine of 450 degrees. And we'll go back and we'll look at our half angle formulas. And that looks like this one, where T is going to be 450 degrees. So this should be the same as the tangent of half of that. And half of 450 degrees is 225 degrees. Okay, so we're going to go through the same process. We're going to figure out what quadrant we're in, and then figure out the reference angle. So in quadrant 3, to find the reference angle, you take the angle and you subtract 180 degrees from it. All right, so our reference angle is 45 degrees, which is the middle finger. And whenever we're doing the tangent, it's the square root of the bottom fingers, which is 2, over the square root of the top fingers, which is also 2. So the square root of 2 over the square root of 2 is 1. And in quadrant 3, tangent is positive, so it's positive 1. All right. We're going to do a way longer problem. This one has multiple parts to it. So on example 2A, we're going to determine the quadrant in which u over 2 lies. And that won't take long. The big part of this question is B part, which is to find the value of sine of u over 2, cosine of u over 2, and tangent of u over 2. Okay. And then you have to be given some information, like given the problem. Those are the directions, and the problem is that sine of u is negative 3/5, and pi is less than u is less than 3 pi over 2. All right. So this is telling you that u is in quadrant 3. So let's draw u. All right, and then the sine is 3/5, so opposite is 3, hypotenuse is 5, adjacent is 4. And then if we need to find the sine, cosine, and tangent of half of u, if you guys look at the formulas, then we definitely are going to need the cosine of u. In tangent, we also need the sine, which we already have. So I would go ahead and just tell that the cosine of u is negative 4/5. We're going to use that quite a bit. Okay, so the A part, we're going to determine the quadrant that u over 2 lies in. So what I would do is just pick an angle that's between 180 degrees and 270 degrees. So like you could pick 100 degrees. So half of 100, between 180 and 270 is 200 degrees. And then half of that is 100 degrees, which is in quadrant 2. Right? Then you could pick another one. Like if you wanted to pick one closer to 270, you could pick 260 degrees. Half of 260 degrees is 130 degrees, which is also in quadrant 2. So any angle that we pick between between 180 degrees and 270 degrees, half of it is going to be in quadrant 2. So u over 2 lies in quadrant 2. Okay, so we're done with that. We do need that to do the rest of it. But let's go ahead and find the sine of half of u. All right, and so like I said at the beginning, we're going to either do the positive square root or we're going to do the negative square root. So since u over 2 is in quadrant 2, for the sine, it's going to be the positive square root, because sine is positive in quadrant 2. All right, then I will just write the formula. All right, and then we already found that the cosine of u is -4/5. So I can take that -4/5 and just put it in the place of cosine of u. So it'd be 1 minus -4/5 or 1 plus 4/5. All right. Then it was just some algebra and taking care of fractions and radicals and all that stuff. And so to get rid of this little fraction of 4/5, what we would do is multiply by 5. And then just to keep it legal mathematically, we would also need to multiply the denominator by 5. All right. And then if you have the square root of a fraction, what you can do is break it apart into the square root of the numerator over the square root of the denominator. And the square root of 9 is just 3. So eventually this simplifies down to the sine of half of u is equal to 3 square root of 10 over 10. All right, and now we're going to do it all over again for cosine of half of u. All right, now we know that u over 2 lies in quadrant 2, and if we're going to do the cosine, we are going to use the cosine formula, and if it's quadrant 2, we're going to take the negative square root for the cosine. All right. And just like the last problem, in the place of cosine of u, we are going to put in -4/5. All right, and then we have that same issue. We have that little fraction, so we're going to multiply by 5. And then we'll just simplify it down. So the cosine of half of u is equal to the negative square root of 10 over 10. Right? And then because we found the sine of half u and cosine of half u, we can use the quotient identity to find the tangent of half of u, or we could use the formula. It's completely up to you. I think it's a little easier just to use the quotient formula. Okay, so in the place of sine of half of u, I'm going to do 3 square root of 10 over 10. In the place of cosine of half of u, negative square root of 10 over 10. And then to divide by a fraction, we're going to multiply by the reciprocal. And then lots of stuff cancels out. So these 10s, the square roots of tens. And so what we're left with for the tangent of u over 2 is just -3. All right, so your assignment today is going to be a worksheet.